Question 6, a model for the GDP, gross domestic product, GDP, gross domestic product in millions dollar is F of t equal 209.5t plus 1136.1, where t is years since 2000. T equals 0, corresponding to the year 2000. Find the percentage rate of the change of f of t for t greater than or equal 0, less than or equal 12. Now, what is the percentage rate of the change? It is here. This is the notes. The relative rate of the change of the function f at x per unit change in x is f prime of x over f of x, and change to percentage times by 100%. And this 100 times f prime of x over f of x percent is called percentage rate of change of f at x. So actually, relative rate of the change, this one is the relative rate of the change, is change to percentage, and this we call percentage rate of the change. But actually, they are equal. So for this question, percentage rate of the change is f prime of t over f of t is the relative rate of the change, and times by 1. 1 is 100%. So we do f prime of t. F prime of t is f function take first derivative. This function take first derivative will be 209.5 times by 1 times t to the power 1 minus 1 is t to the power 0, which is 1. So it's actually is 209.5. Add the constant term take derivative is 0. Constant term take derivative is 0. So it's going to be f prime of t equal 209.5 over f of t. Function f of t is this one, and copy done. And times by 100%. 100% actually is 1. Then equal to 100. 100 times 209.5. 20. So you move decimal point to the right 2 position. Fill in 0. So we got 20950 over this denominator and put percent sign. That's the answer. This percentage rate of the change of f function. And question 7 is the price P and the demand X for a product are related by the price demand equation. P equal 20 minus X over 500. A, find the elasticity of demand E of P. What is E of P? E of P definition is elasticity of demand. Demand is X in terms of our price P. At price P, we call E of P is elasticity of demand at price P. We call E of P. Define equal negative relative rate of change of demand F over relative rate of the change of the price P. P is the price, F is the demand function. F is F in terms of price equal X. X is how many units of demand. So relative rate change of F is F prime of P, first derivative over F of P. Relative rate change of the price is the price take derivative over the price P. And equal negative F prime of P over F of P. And P take derivative to the P is just 1 over price P. And then reciprocal get negative, this become P over 1 and times it and become P times this reciprocal become P over 1. Denominator 1 over P, reciprocal become P over 1 and times it and become P times F prime of P over F of P. And this is called elasticity of demand and represented by E of P. So E of P equal negative P times F prime of P over F of P. If greater than 1, the demand is elastic. If it equal 1, the demand is unitary, unit. And because relative rate of the change of demand, if greater than relative rate of change of price, then the demand is elastic. If equal, that means relative rate of the change of demand is equal relative rate of the change of the price, equal, then the elasticity of the demand is unitary. If less than 1, that means relative rate change of demand is less than relative rate change of the price, then the demand is inelastic. So this question asks you E of P. E of P is equal to negative P times F prime of P over F of P. So we need to figure out what is P. P is already, P is P, and we need to figure out F prime of P. What is F of P? Is X equal F of in terms of P. And given demand equation is P in terms of X. P equal 20 minus X over 500. So first of all, we have to change to become X in terms of P. X equal. So we need to solve this for P. So solve for this for P. First of all, we times denominator 500. P times 500, 500P. 20 times 500 and get 10,000 minus this term times 500 cancel, get X. And solve for the X. We will write X in terms of P. So move this minus X, move to the left. Minus X change to plus, become X equal. 10,000 still on right side, don't change. And the 500P, move to the right side, change this positive and change to negative. That's the quick way to do. The slow way is use addition property and the subtraction property. The quick way is move over, change the sign. We are going to isolate X, find out X in terms of P. So we got X equal this one, so we let this is F of P equal F of P equal 10,000 minus 500P. That's F function, which is a demand. F of P is X. X is the demand, how many units. And this in terms of P, in terms of the price. So after get this function, so we do elasticity. E of P equal negative P times F prime of P, which is this function, take first derivative. This function, 10,000 take derivative is 0. Negative 500P take derivative is negative 500. So F prime of P is negative 500. Prime of P equal negative 500. So then P times negative 500. F of P, FRP is this, 10,000 minus 500p. And negative times negative become positive, 500p over 10,000 minus 500p. Then you can cancel 500 divided by 500 divided by 500 divided by 500 each term. Cancel 500, get p. 10,000 divided by 500, get 20. Minus 500 cancel, get p. So this is negative times negative become positive. So this is ERP, function. After get this, then next B, find each of the following and determine the elasticity of each demand. So find out E of 4, E of 16, E of 10. When price is $4, so you plug it in. E of P equal P over 20 minus P. So P use 4, plug it in. 20 minus 4. Get 4 over 16, get 1/4 is less than 1. And if less than 1, if ERP is less than 1, then the demand is inelastic. Now, E of 16, you plug 16P in P. P is 16 over 20 minus 16 is 16 over 4, get 4. 4 is greater than 1, so you say the demand is elastic. Then E of 10, P is $10, plug in P. P is 10, plug in. Over 20 minus P, P is 10. So get 10 over 10 equal 1. So the demand is unitary, unit demand, unitary demand, equal. They are equal 1. So C, find about the revenue. Now let's look at the formula about the revenue. This is revenue. This is in your notes, chapter in the notes, chapter 3 notes. Revenue function is R of P equal P times X. What is X? X put in terms of P, so it's P times F of P. And this revenue, if you take derivative F prime of P, you will use product rule. First of all, P take derivative equal 1 and times second function F of P plus the first function do not take derivative is P times second function take derivative is F prime of P. And then F of P, factor out F of P. So this become 1. If you distribute it in, this is F of P plus and factor of F of P. So here denominator divided by F of P. And this equal this, because if you distribute it in, you can see that's first term product, get this. Distributive in times second term F of P cancel is P times F prime of P. So they are equal. Now you factor F of P. So this F of P divided by F of P, you got 1. And plus, then this, you divide it by F of P, you got this. So then F of P equal, this is 1. And what is this? This is just negative ERP, because ERP equal negative this. So this is equal negative ERP. And if ERP, FRP is how many units? How many items of demand, so always positive. And here, if ERP is greater than 1, more than 1, then 1 minus a number greater than 1 is negative. Then become negative. Negative times positive become negative, which is less than 0. So if ERP is greater than 1, the demand is elastic. The R prime RP is going to be negative. If the first derivative of the function is negative, then original function RRP is going to be decreasing. That means the RRP is decreasing. Here, RRP, if first derivative is negative, then the original function of its decreasing function. R prime RP is a slope. Its slope is negative. The original function is decreasing. So slope is a fall down to the right. So its slope is negative. So that's decreasing. Then if equal 1, if ERP equal 1 unitary, then demand is unitary. This 1 minus 1 is 0. Then R prime RP is 0. R prime RP is 0. That means the graph is a horizontal unitary. Then if ERP is less than 1, so you subtract 1 is still positive. Positive times positive is positive. So R prime RP is positive. That means the original R function is going to be increasing function. Greater than 0. So in elastic demand, the original R function is increasing. Then elastic demand, then the revenue is decreasing. Now, if demand is elastic, then change in revenue and the change in unit price move in opposite direction. Like this demand is elastic, then change in revenue. If the price increasing, then the revenue decreasing. So the slope is negative. Now, if demand is inelastic, that means the revenue is decreasing function. That means price increasing, the revenue also increasing. So it's the same direction. If demand is inelastic, then the change in revenue and the change in unit price move in the same direction. Then next one is a table. If the ERP is positive and less than 1, the demand is inelastic. That means the demand is not sensitive to change in price. That is, percentage change in price produces a small percentage change in demand. And for revenue, a price increased will increase the revenue. And if ERP, elasticity, ERP is greater than 1, the demand is elastic. And what means demand is sensitive to change in price. That is, a percentage change in price produces a larger percentage change in demand. About the revenue, a price increase will decrease revenue. Then ERP equal 1, the demand is unitary, and means a percentage change in price produces the same percentage change in demand. So following, in elastic demand, ERP is less than 1 is in elastic demand. Increasing revenue, because R prime RP is positive, and the R function, RRP. First derivative is positive, then function is increasing function. And if elastic demand, which means ERP is greater than 1, is elastic demand. The decreasing revenue, the revenue decreased because R prime RP is negative, so the revenue is decreasing. From this, we are going to do the C. If the current price is decreased, will revenue increase or decrease at p equals 4 and at p equals 16? So first, E of 4, because E of 4 equal 1/4 is inelastic. So if the current price is decreased, then the revenue also decrease because are same direction. In elastic, if the current price increased, the revenue also increased. If current price decreased, then revenue also decreased. They are in the same direction. And the E of 16 equal 4. Here E of 16 in previous one, we got E of 16 equal 4 is elastic demand. When elastic demand, the revenue and the price is opposite direction. So if current price decreased, the revenue will increase. If current price increased, the revenue will be decreased. Then next one will be question 8. Question 8, we talk about the chapter 4, optimization problem. A drug and that stimulates reproduction is introduced into a colony of bacteria. After 10 minutes, after 10 minutes, the number of bacteria is given approximately by, this n means the number of, in terms of t minutes, t is in minutes, equal 1000 plus 30t squared minus t cubed. T is how many minutes? And T is between 0 to 20 minutes. Then A, when is the rate of growth? Rate of growth is per minute increasing or decreasing how much? That's the rate of the growth. Ask you, in which minutes, in which interval of minutes, the n prime of t, the function n prime of t we call rate of growth. Increasing in which minutes this function, first derivative of n of t, total number of big bacteria after t minutes is n of t, and take first derivative is rate of growth. This function increasing or decreasing in where? So we have to use the increasing decreasing test. If the first derivative positive for every value x in an interval AB, then f is increasing on the interval AB. Because if first derivative is the slope of tangent line. If the slope of this tangent line rise up, the slope is positive. From left to right, if it rise up, then slope is positive. And the function is going to be this way, is increasing. Or function this way, this one, concave up, increasing. This one is concave down, increasing. The function is concave down, increasing. Because the slope is go from left to the right, it's positive. This from left to the right is a positive slope. Then the line, tangent line, go this way. And your curve can be concave up, increasing, or concave down, increasing from left to the right. This is going increase. So increase. If first derivative is negative, then every value on x on the open interval will be decreasing. And the negative is the slope of tangent line. If it fall down to the right, then this curve, this function is going from left to the right, is a decreasing function. Like this one is a concave arc decreasing. Like this go from left to the right. If the line go this way, is the slope is negative. Then the this function, the original function, is a concave from left to right, is go decreasing and concave down. So if f prime of x equals 0 for every x in the interval a, b, then f is a constant on that open interval a, b. So use this increasing test or decreasing test, then we are able to do it. And we are going to determine whether this function is increasing or decreasing, so we have to do this function, take derivative. So this is the f prime of t function. You take derivative, become fn double prime of t. And if positive, then this function take derivative, we get n double prime of t is positive, then this function, original function, n prime of t is increasing. If this function take derivative, get n double prime of t. If negative, then original function n prime of t is decreasing. So we take derivative. So n of t is this one. 1000 take derivative is 0. Plus 30 times 2 is 60. T to the power 2 minus 1. So get this one, first of all, you take derivative, n prime of t, take derivative. 1000 take derivative is 0. 30 times 2 is 60. T to the power 2 minus 1, so t to the power 1. Minus 3 go from 3. T to the power 3 minus 1, so get 3t squared. This is n prime of t. And this first derivative, and take derivative again, get double prime. And double prime of t, 60 take derivative is 60. Minus 3 times 2 is 6. T 2 minus 1, so t get t. This is a second derivative. If a positive, then n prime of t increasing. So if you let this greater than 0, solve for t. So you move this over, change the sign, get 60 greater than 6t. And divided by 6, cancel, get 10 greater than t, and rewrite as t less than 10. And since t is greater than or equal 0, greater than 0, so for increasing, since this is a positive, we get t is less than 10. So you say t is between 0 and 10 because t is started at 0. So is t greater than 0 and less than 10, then n prime of t is increasing function, increasing on the interval 0 to 10. Now, if you let n double prime of t less than 0, then the n prime of t will be decreasing. So let n double prime less than 0 and move over 60 less than 60 and divided by 6. You got 10 less than t, and rewrite is 10 greater than t greater than 10. Greater than 10 up to 20. So the t is greater than 10 and less than 20 minutes. So on the interval 10 to 20, the n prime of t is decreasing function. Second one, inflection point. What is the inflection point? Is they've given you a function here, and given you a function first is concavity. Finding the inflection point. How to find inflection point? So you solve for f double prime of x. the original function, take second derivative. If that equals 0, solve for the x. Solve for the x, and then you check to the left and to the right. If the sign is different, that is the inflection point at original function f have inflection point at x. If f double prime change the sign from positive to negative or from negative to positive at c, then at c, f of c is an inflection point, which is concavity changed. Change from concave upward, then go concave downward. Concave upward, the f double prime is positive. Concave downward, f double prime is negative. So concave upward, then change to concave downward, and this is a point of inflection. Or concave downward, f double prime is negative. Change to concave upward, f double prime is positive. Then, and that we call point of inflection. Is if f change the concavity at c, then cf of c is an inflection points. So this question we are looking for inflection point of n. N is n. So we take n double derivative. We figure out n double prime of t equals 0. Let n double prime of t equals 0. N double prime is 60 minus 60 equals 0. And move over and change the sign. Got 60 equals 60 divided by 6, t equals 10. And check. To the left, to the left, less than 10, like 9, you plug it in. 60 minus 6 times 9 is a positive. To the right, like greater than 10. To the right of 10 is greater than 10, like 11, you plug it in. 6 times 11 is 66. Subtract from 60 is a negative 6, is negative. Different sign. To the left, to the right, different sign of t equal 10. Different sign. So t equal 10 at this point has inflection. It's inflection points. And now you figure out when t equal 10, you plug into original function n of t. N of t given is this 1000, plug in plus 30 times 10 is t is 10 minutes, 10 squared minus t is 10 cubed. Plug in. So you got 1000 plus 30 times 10 squared is 100 minus 10 cubed. 3 zeros. Cube have 3 zeros. Square you will have 2 zeros. And you got 10,000 plus 3,000 minus 1,000 plus 3,000 minus 1,000 get 3,000. So this point when t equal 10, n of 10 is 3,000. And that is the inflection point is when time is 10 minutes, the bacterial has 3,000 bacterial. And that's inflection point. And next, what is the maximum rate of growth of n prime of t? And this one you can use first derivative test or second derivative test to do. We can use second derivative test to do is easier. So if given original function is f function and you compute first derivative and compute second derivative, then you solve for the first derivative f prime of x equals 0. Let first derivative equals 0, solve for the x, and get those critical number. Get those critical numbers c. If you plug into second derivative, if negative, then f of c is relative maximum, which is concave downward. Second derivative is negative, that means concave downward. And this point is make first derivative equals 0. Slope is a horizontal line. tangent line slope is 0. Tangent line is a horizontal line. And this second derivative is net concave downward. So this is a relative maximum point because all the function is below this, less than this. So this is a relative maximum. If a concave upward, which is a second derivative is a positive at this point, and the first derivative equals 0, then tangent line is a horizontal line. So then at this point has a relative minimum because the curve is go up. And this is the lowest point minimum, so relative minimum. So original function, you take first derivative and take second derivative. Let first derivative equals 0. Solve for the x, get critical number. And those critical number plug into second derivative function to check. If positive is relative minimum. If negative is relative maximum. Original function have a relative maximum. So let's do this. Now is this function n prime of t is we call rate of growth function. This function you need to take first derivative, which is n double prime. That's the first derivative of this function. N prime of t we already find out in a and b is this one, and take derivative of this n double prime. This one actually is a first derivative of n prime of t. You let this first derivative equal 0, solve for t, get t equal 10. We call critical number of n prime of t. And plug into second derivative of this. So this one take first derivative is take derivative, and take derivative again is a triple prime of t. And so this take derivative again. 60 take derivative is 0. Negative 60 take derivative is negative 6 times 1 is negative 6. T to the power 1 minus 1 is t to the power 0 is 1. So get negative 6. When t critical number is 10, you plug in is still negative 6 because the constant doesn't change with t. So it's less than 0. If less than 0, then original function n prime of t at t equal 10 has a relative maximum. If greater than 0 has a relative minimum, if opposite. If less than 0 has a relative maximum, it's just opposite. So then we got when t equal 10 have a relative, when t equal 10, at t equal 10, n prime of t has a relative maximum. And what is the relative maximum? You have to plug this 10 into n prime of t. N prime of t is this function you plug in. T is 10, plug in. Get 60 times 10 minus 3 times t is 10, plug in 10 squared. So get 60 times 10 is 600 minus 10 squared, 2 squared, 2. So you will 20. 100 times 3 is 300 and subtract is 300. So you will say the maximum rate of growth is 300 bacteria per minute. Per minute growth, 300 bacteria is maximum rate of the growth.